Hello everyone, welcome to Engineering Archives. Let's look at our practice problem number 3 for the chapter Co-planar forces. This question says, determine the magnitude and direction measured counterclockwise from the positive x-axis of the resultant force of the three forces acting on the ring A. Take F1 equals to 500 Newton and theta equals to 20 degrees. So F1 is equals to 500 newtons while theta is equal to 20 degrees. We will also need this angle, and we can find this angle using this triangle that they have provided to us. And using the triangle, we get tan of theta, or tan of phi, is equal to 3 by 4. And we get the angle phi, tan inverse 3 by 4, which would be equal to 36.87 degrees. So this angle will be equal to 36.87 degrees. Now that we have all our forces and the angles, we can simply resolve them into their components, then add them to get the sum of components along the x and the y axes, and then we can use the resultant formula to find the resultant force. Notice that all the forces are acting on a ring in the center. Whenever they give you a ring in the center, you can assume that all the forces are acting on the point at the center of the ring. So let's find the sum of all the components along the x-axis first. Components along the x-axis. (400) cos of theta, cos of 30 degrees, plus 500 sine of 20 degrees, minus 600 cos of 36.87 degrees would give us 37.42 newtons. For the components along the y-axis, we get 400 sine of 30 degrees plus 500 cos of 20 degrees plus 600 sine of 36.87 degrees, and we get 1029.847. So remember to not round off your figures before you get the final answer. Only round off once you have your final answer. Now that we have our components, sum of components along the x and y axis, we can simply find the magnitude of the resultant force by applying the resultant force formula, and the answer that we get is 1030.5 newtons for 1031 newtons. Now that we have magnitude of our resultant force, we can find the angle by drawing the vector triangle. The sum of components along the x-axis is equal to 37.42 newtons, while component along the y-axis is 1029.847 newtons in magnitude. The resultant force is 1031 newtons. Applying the trigonometric identity of tan theta, we get tan theta equals to 1029.847 divided by 37.42, and we get theta equals to 87.9 degrees. So this is the simple procedure for this question. Thank you very much. See you in the next video.